Okay, my dear students, let us discuss another topics from D block elements. Let me check the video. Okay, first I will go to the topics oxidation number, oxidation state, oxidation state of D block element. One of the important point D block elements, D block elements show a variable oxidation state. Variable oxidation state. What is that meaning? Group 1 alkali metal shows +1, group 2 alkali and earth metal shows +2. But D block shows +1, 2, +8. It shows this. It shows we have a lot of examples. We have a Fe2 plus, we have a Fe3 plus, we have Cu plus, we have a Cu2 plus, like that. Okay. Therefore, why they are showing? It is because we know that D block general electronic configuration is n-1 D1 to 10 ns1 to 2. If only ns electron has been involved, its oxidation state may be +1 or +2. If ns only has been would have been involved, but not only ns, both ns and n-1 d electrons are involved. Therefore, it shows a variable. It shows variable oxidation state. This is a problem. The alkali metal it is ns1. The alkaline earth metal it is ns2. Only ns electrons are involved. But in D block, not only the ns electrons, but n-1 d electrons also involved in the bond formation. That's why D block element shows variable oxidation state. Let us check their oxidation state in detail. Let us check the 3D elements. 3D elements, you know that the scandium has 3D1 forest. 3D1 forest. It shows following oxidation state +2 and +3. Titanium shows 3D2 forest 2. It shows +2 and +3 +4. What is this +2? This +2 belongs to this one, forest electrons. Okay, not only the forest electron, d electrons also give. When one d electron gives, it becomes +3. When second d electron also give up, when second d electron also given, it becomes +4. Then vanadium, that is 3d3 forest 2, that is +2 +3 +4 +5. Chromium 3d5 forest 1. Please remember 3d5 forest 1. Therefore, chromium shows +1 +2 +3 +4 +5 +6. Okay, just careful about it. This +1 because of the one electron in the chromium. Now we can go to the manganese. Manganese 3d5 forest 2, that is +2 +3 +4 +5 +6 +7. Now let us go to the iron. Iron is 3d6 forest 2. What is the problem of 3d6? This is a 3d6. 1 2 3 4 5. This is a 3d6. It shows +2 +3 because of this, +4 because of this, +5 because of this, +6 because of this. These paired electrons do not take part in the bond formation or oxidation. It does not take part in the oxidation. Careful. Now, iron Cobalt. Now cobalt, we have a 3D 7 4s2. What is that? This is cobalt. Okay. We have a +2, we have a +2, +3 because of this, +4 because of this, +5 because of this. Now cobalt nickel, when you come to the nickel, you have 3D8 forest. What is a nickel? +2, +3, +4. Paired electron do not take part in the bond formation. +2 because of this one, +3 because of this one, +4 because of this one. Now copper, 3D10 4s1. Copper, I may write like this. Here you have +1, +2. These are the two oxidation states. Copper shows +1 because of this one, +2 because of this one. Then sorry, this is not like this. 3D10. Actually, it shows +1, +2 because one electron is lost from here. That is because actually this was like this, 3D9 4s2. Here it become 10 because of the extra stability. Actually that electron, the 10th electron here, actually belongs to S. Fine? Yes. Now zinc 3D10 4s2. It shows only one oxidation state, +2. Zinc shows only +2. So what you have understood from this discussion? You have understood that D block shows variable oxidation state. Both S electron and D electrons are involved in the oxidation. But in the case of a D electrons, only unpaired electrons involved in the oxidation. Only unpaired electrons involved in the oxidation. Remember that point. Only unpaired electron involves in the oxidation. The maximum oxidation state of 3D series is +7. Because +2, +3, +4, +5, +6, +7, then decreasing. Therefore, oxidation number increasing up to the middle, then start to decreasing. Okay. Therefore, we can conclude following points. These are the conclusions. Let me write the conclusion. The first conclusion is it shows transition metal shows variable oxidation state. Most stable and common is +2. Everybody shows the +2. Third, oxidation state increases up to middle. Oxidation state increases up to middle, then decreases. It increases up to middle, then decreases. Okay. Both NS electrons, NSN, N-1D electrons involve in the oxidation. Zinc shows +2 only. Copper and chromium show +1 also. This is all about the oxidation state of transition metals. Now I just write more points here. Down the group, tendency to show higher oxidation state increases. Among transition metals, osmium shows highest oxidation state. Highest oxidation state, that is plus 8. Osmium shows highest oxidation state, that is plus 8. These are the different properties of associating with the oxidation state of transition metals. Okay, yes. Now, properties of oxides. Now we will go to properties of oxides. Properties of oxides. Properties of oxides. Transition metal oxides. Transition metals show varieties of oxides. Varieties of oxides. Because they can show variable oxidation state. Variable oxidation state. I will tell you some examples. Suppose MnO here plus 2, Mn2O3 plus 3, MnO2 plus 4, Mn2O5 plus 5, Mn2O7 plus 7, Fe2O3, FeO, Fe3O4, CrO2, CrO3, CrO. Okay. Here it is plus 2, plus 4, plus 6. This is another feature of transition metals. That shows this type of oxides. Fine. And all oxides are basic, but basicity decreases when oxidation number of transition metals are increased. Higher oxidation state higher oxidation number metal oxides are acidic. Higher oxidation number metal oxides are acidic. Okay. Therefore, transition metal oxides are generally classified as acidic, basic, and amphoteric. They are generally classified as acidic, basic, and amphoteric. Transition metal oxides are. They are generally classified as basic, amphoteric, and acidic. Basic are lower oxidation number metal oxides. Example, +2 and +3. Titanium oxide, vanadium oxide, chromium oxide, V2O3, Cr2O3, Mn2O3, like that. Intermediate oxidation state, oxidation number metal oxides. Example, CrO2, MnO2, that is +4. Okay. Example, oxidation number is +4. Higher oxidation number metal oxides. Examples are Mn2O7, that is +7. Cr2O6, that is +6. Example oxidation state are +7 and +6. That is +7 and +6 oxidation state transition metal oxides are acidic. Therefore, +1, +2, +3, these transition metal oxides are basic. +4 transition metal oxides are amphoteric. +7, +6 are acidic. These are acidic. Okay. Yes. Now I will go to another topics. Comparison between first row and comparison between first row and second, third row transition metals. That is first row one side, second, third row transition metals. Okay. We know that here 3D orbitals are gradually filled. But in this case, 4D and 5D are filled. Here in this series, elements elements have different properties, but here in this series elements show similar properties. Here no F block is involved. No F block involved. But here F block elements involved. There is a regular electronic configuration, but here irregular electronic configuration. Size increases down, but second, third group have same size because of Lanthroid contraction. Here maximum oxidation state is oxidation number +7. Here maximum oxidation number is +8. Less tendency to show higher oxidation state, oxidation number, but here more tendency to show higher oxidation number. That is, second and third series elements have higher tendency to show higher oxidation number, but first series have that tendency is very less. Similarly, here maximum coordination number is +6. Here maximum coordination number is greater than +6. Okay, these are the some points of comparison. Okay, now with this I finish our D block. Let us move to F block. Thank you.